Hey, welcome to Tag Talks. I'm Paul Schiller, Product Marketing Manager, and I'm here today with Paul Briscoe. He's our Chief Architect, and welcome, Paul.
Hey, Paul, how you doing?
I'm doing great, and I should also mention that Paul is a SMPTE Fellow, lifetime member, and we'll talk about that when he talks about SMPTE in a little bit. Anyway, let's get started with some basics around one of our newer features, content matching. Why don't we just start with what the basics are of content matching and what problems it helps solve?
Wow, where to begin? Well, content matching does something fairly new. You know, we keep track of content everywhere we can touch it. We probe it, we monitor it, and we know everything about its technical parameters. What we don't actually know, and this is kind of an industry-wide thing, is we really don't know what's inside the video and the audio. And so it's fine to be able to say, yes, I guaranteed that this file that I think played out went down this path and was delivered to this destination. But you don't know along the way if a routing error was made or something. And so content matching is an ability to, at every point you touch content, be able to validate the actual essence, the video and the audio content, is correct.
Okay, so let's expand on that. You being one of the authors of the SMPTE standard, and you can tell me what that standard is and which which content matching is built on, right? So tell us about what the standard is and how it's being used today with content matching.
Yeah, so it's an older standard. It's been worked on for a fair while. SMPTE had a study group, which turned into an ad hoc group, kind of a minor detail, but it went for a number of years studying the problem of lip sync. In the early days of compressed television, there was a lot of trouble with lip sync, and it was felt a standard was necessary to be able to detect and potentially repair lip sync problems on the fly. So the work was undertaken to understand this. A study was done. Numerous proposals were provided. And one proposal from Grass Valley, at the time Miranda, for a fingerprinting technology was accepted as the basis of the standard. So on that basis, myself and a committee wrote this standard. And what it does is very unique. If you think of fingerprint or think of DNA as a forensic technology, it's a summary way of identifying you. If I have your fingerprint in hand, I can spot you by your fingerprint anywhere else, right? And, even as you get older, even as you degrade over time, your fingerprint doesn't change so much, right? And I can still identify you. So what we do in this standard is we extract from the video and audio uniqueness. So from every video frame, we extract some uniqueness about that frame using an algorithm, and we do the same for audio. And we create for, let's say, each frame of video and each equivalent frame's worth of audio, we create a very, very small data fingerprint through this algorithm that says, okay, this little bit of data represents a picture of Paul Schiller. Now, that isn't necessarily unique in the universe. If I reduce a picture down to small data, many pictures will probably reduce to that small data. But in television, every picture is in sequence. So if I match your face in this picture and you move, and in the next picture I match your face again, you match your face again, and then it switches to me and I match my face, I can understand that because I'm matching over time and consistently, I have found the content. And that's the basis of this standard. So what we do then is we create these fingerprints when we have our first hands on the video, let's say at the point of origination. We then send that video somewhere downstream to the next stage, and we probe it there. How do we find it? Well, I have a fingerprint in my hand that I've derived from this video and audio. At that next stage, I generate fingerprints from video and audio again, and I start looking for matching fingerprints between the source upstream and the monitoring point downstream. And I look across time because I know it's going to be later downstream than upstream. Time goes forward. So when I find that match of video upstream frame to video downstream frame fingerprints, I then look at the next frame and the next frame and the next frame. And if they continue to match, I say, okay, I've matched the video content, and I do the same for the audio. And I now have some data in my hand which tells me some interesting things. Tells me what the latency of video is from the source. Tells me the latency of the audio from the source. I can now measure lip sync. So I've actually validated that the content I'm measuring at that downstream node in any format, which is a unique part of our solution, is still the same video and audio. And its latency is so much. So I've met the lip sync measurement challenge, even though that problem has kind of gone away. But I can now do other things by knowing that I have found the same video downstream. And the more important aspect of that is when I don't. If you're sending your picture downstream and I go to that probing point and I can't find your picture anywhere, I know the wrong thing is being delivered there. Even if the technical parameters all say it's the right thing, that content's wrong. So that's the basis of what's underneath this technology, is that technique.
Paul, that's a really good technical explanation. But from the perspective of our customers like TV engineers and operators, what makes fingerprinting based matching better, or a better approach to, say, like time-based correlations or simple metadata comparisons?
Well, metadata represents a story about the data at the instant it was attached to the media. But again, downstream, if somebody switches the video content in some system en route to the next destination, the metadata may not reflect that change. Only the picture has changed, right? Or the sound has changed. So an application example, let's not talk about the case where somebody makes a mistake and the wrong program goes down the wrong feed. Let's talk about a real case. A commercial is supposed to be inserted. When the commercial is supposed to be inserted, the video is going to change to the commercial. Right now, the automation system will say, yes, I played the commercial. And it'll say, yes, I played the commercial for toilet paper. But was it really the commercial? And was it really for toilet paper? Did it really get inserted? You need to watch the picture to know if that happened. And that's what this fingerprinting content matching technology does. It literally watches the picture. And when that commercial cue comes from a SCSI trigger, for example, we can look and say, yes, the content changed. And yes, it's in fact the right commercial. Or we can say, you know what, the commercial didn't get inserted. It just went to black for 30 seconds. We know that despite the fact, or the wrong content was inserted for 30 seconds. So we know that despite the fact that the metadata and the system may not see anything wrong with the inherent transport delivering it from A to B.
So, yeah, you mentioned a lot of complexity in there. So basically, even the operators are dealing with very complex hybrid workflows, whether it's live production or play out, OTT, or traditional delivery. How does CMT help unify that visibility across these different environments?
Well, this is a perfect match, no pun intended, for content matching. Because in distribution, where you come out of a sports venue and you go perhaps to over-the-air, you go to cable, you go to various OTTs, and each OTT produces multiple versions of the same program, you need a lot of eyeballs watching pictures and listening to sound to make sure you're delivering the right thing to these destinations consistently and at quality. And I'll talk more about quality a little later here. But by using content matching, instead of eyeballs, you can monitor every point and every version of that content, because content matching doesn't care about what the technology upstream is. It could be 2110, it could be a transport stream, it could be OTT. It doesn't matter. It's the video and audio. So we throw away the transport, so to speak, in content matching, and we concentrate only on the video and the audio. The rest of the tag platform, of course, concentrates on everything else. This is on top of what we do right now. So we're validating what the customer already thinks they know is going on, and we're telling that operator that, yes, indeed, everything you're sending everywhere is the right thing, and if one of it isn't right or doesn't get there, then we can advise the operator. But the other cool thing, I mentioned quality. In OTT especially, where we have quality variants that offer, delivery to devices as efficiently as possible, the qualities can be wrong. You can be delivering too much quality to somebody's little cell phone screen or too little quality to somebody's bigger screen. Content matching can be used in conjunction with quality measurements. For example, SSIM, quality measure, which we use. And so when we match content, we can then throw SSIM to the task, let it look at the matched content, and measure the quality degradation that's occurred between the point upstream and the point of measurement. And we can do this through a huge long path, many, many nodes, many, many formats. But as your quality is degraded on the way to the consumer, that's reality, right? Uncompressed is better than what you send home. We can measure that degradation and keep an eye on it. And if your quality isn't what you expect it to be at a certain point, we can alarm and say, hey, you were expecting a better picture here. Something's not right. And we do that independently, completely of metadata.
Just to follow up to that, what you're just saying is, some users or even existing users, what you just said, even our listeners might think, well, this is just a QC, and others might see it as just a safety net. How do you see its role in the day-to-day of in a media control room? You gave us one example, or even a network, an operations center.
Well, it's not a tool you use actively like looking at an alarm. It's a tool you apply to a system and let it sit there quietly doing its job, and it will alert you when things are not what you expect. And that can mean a lot. It can mean the quality, it can mean the latency, it can mean the lip sync, it can mean the content doesn't match what you expect it to be. There's a lot of things we can do with this. But what we're delivering, I think, to the customer is confidence. By putting this across a path, for example, and monitoring for the critical things it can monitor for in addition to everything else we do, we're raising the confidence level of the customer that their system's ability to deliver their content and thus their revenue is in good shape, and they can have confidence that it's working. So I know it's kind of a high-level thing to say, but really what we're doing with our product and what this adds to our product is additional confidence for the user in many ways, such as content verification, latency measurement, the other things I measured, quality measurement, and other things we'll add to it in the future, which I'm not at liberty to talk about.
So you mentioned SSIM earlier, and that's just another one of our features. How does content matching amplify not just SSIM, but maybe even penalty box or other features that TAG has in the platform?
Right. Well, so SSIM is a great example because you apply SSIM at different points through a system to measure the quality and what the quality behavior is as it goes through processing. By being able to match the content, we can now perform SSIM very quickly and directly because it does require matching of the frames. And if we do that only with metadata can sometimes not necessarily lead you to a frame accurate match, especially across different video formats. But using content matching means we can do SSIM measurement on any format we support. So that's a really powerful thing. As far as penalty box, alarming and notification, all of the things that Content Match monitors are probed and monitored along with everything else in TAG and applied to our templated thresholded alarm system. So if lip sync falls out of range, we can fire an alarm. If content doesn't match, we can fire an alarm and so on. So it's fully integrated with the subsystem that then lights up penalty boxes and delivers alerts and does all of the usual things that we do.
Yeah, all of these things are certainly innovative, and so innovation is really at TAG's core mission, right? And this is also a great example, the content matching I'm talking about. It's a great example of how we've taken a dormant SMPTE standard and made something out of it. What drove the decision, and what does it say about TAG's approach to development?
Well, we tend to be pretty innovative here at TAG. And in this case, it happened quite organically. I mean, the desire to know more about content downstream and further away from the source, we discovered and intuitively knew was an important thing for customers. Our probing already does that as much as we can without actually watching the picture. But we knew we had available this standard, which literally watched the picture and listened to the audio. I mean, that is key in all of this. It's watching the video pixels and listening to the audio. And the marriage between the two was just so obvious. We didn't think of going anywhere else with this. The standard met the requirement of what we wanted to do. We implemented the standard. We did some optimizations to it, which we'd be interested in knowing if anybody else would like to go back to SMPTE and update the standard, in fact, because we'd love other people to put the fingerprinting in their own technology. So when something goes through their box, we can get fingerprints from it. And customers can build greater ecosystems built on this standard. But the marriage was very organic. When we looked at how it could be used to inform customer decision-making and inform customer information, it was obvious that something based on this was the way to go.
Yeah, so that's great that our other technology companies can incorporate this standard into their own type stuff. But looking ahead, where do you see content matching evolving, and are there any new applications that we're thinking about with this tech and that we haven't tapped into yet, or maybe some of our customers or listeners can tell us about it, right?
Right. Well, we have ideas, and like I said, I'm not going to talk about things that we can't promise. but there are lots more things we can do on top of content matching. And I mean, I would say to every customer, you know basically what the standard does. It watches TV and allows you to make decisions based on the content. So you got some ideas, let us know. I mean, this for us, this is a tool set in our toolbox. This isn't a feature that's wrapped up with a bow. We're building on top of this feature and functionality. And I think the power of being able to know what's inside your content, separate from all of the technical parameters and metadata associated with it, knowing that that actual content going that last mile to the viewer is the right picture, the right sound, in sync, with a latency you understand at a quality you subscribe to delivering, I think is incredibly powerful just in and of itself. But the idea, I think, of customers implementing the standard and putting fingerprinting into their own technology is a really good one. We have, for example, a recent integration with Whitby for the last mile to a set-top box for monitoring actually at the viewer set-top box. And integrating content matching into that, of course, makes perfect sense. We can do quality measurement right as a viewer would see it, the very last mile. So now we can go literally from glass to glass with content matched quality, latency, and performance measurement.
Awesome, Paul. I mean, I don't have any other questions. I mean, this is very helpful for not only me, but I'm sure it's been helpful for our listeners. Anything else you want to add?
And not really. I mean, I'm really happy to share the info. I'm really happy that we're getting the word out. The response to it has been overwhelming. When it was in its beta stage, we had more people using it than we wanted to, and it's been highly successful. And we're continuing to evolve it and build on it. So I'm really glad to see this poor old standard we worked on gain some traction. And moreover, I'm really happy to see us be able to add this kind of intelligence to the tag platform. It's not artificial intelligence. It's actually kind of real intelligence. But if we applied, I don't want to leave a hint, but if we applied AI to this stuff, I think there's other places we can go.
I think you just leaked something, but always a pleasure, Paul. I hope to talk to you soon on other topics.
Love to anytime. Thanks for the time, Paul.
Appreciate it, Paul. Thank you.